Hello students, how are you? I am fine. In previous video, I taught you about the properties of rational numbers for addition. Now today, we learn about the properties of rational numbers for subtraction, multiplication and division. First, I teach you properties of rational numbers for subtraction. The first property is closure property. In addition, what we do in closure property? The sum of two rational numbers be always rational. Similarly, in subtraction, the difference of two rational numbers be always rational. For example, 5 by 4 minus 2 by 3, 15 minus 8 by 12 equals to 7 by 12. Here, 5 by 4 and 2 by 3 are the rational numbers, and their difference is 7 by 12 is also a rational. Now we learn about second commutative property. Two rational numbers cannot be subtracted in any order. In addition, we can add in any order two rational numbers, but in subtraction we cannot be subtracted in any order. For example, 5 by 2 minus 3 by 4. These are two rational numbers and their subtraction resultant number is 7 by 4. But if we change the order, clearly if we change the order, first we write 3 by 4, then subtract 5 by 2, means 5 by 2 subtracted from 3 by 4. The resultant number is minus 7 by 4. Now, the third property is associative property. In this property, while subtracting more than two rational numbers, they cannot be grouped in any order. We can't group it any order because if we change the groups, the resultant answers are different to each other. For example, 3 by 4 minus 2 by 3 minus 1 by 2. Here we make a group 3 by 4 minus 2 by 3, and this subtract gives 1 by 12, then minus 1 by 2 gives minus 5 by 12. But if we change the group 3 by 4 minus 2 by 3 minus 1 by 2, so first we subtract 2 by 3 minus 1 by 2 and it gives 1 by 6. Then 3 by 4 minus 1 by 6 equals to 7 by 12. The both resultant answers are different. So we can say that while subtracting more than two rational numbers, they cannot be grouped in any order, and in addition, they can group be any order. Now, the last property is identity element. Means 0 subtracted from any rational number gives the rational number itself. If we subtract 0 from any rational number, it gives itself. For example, 1 by 2 minus 0 equals to 1 by 2, 3 by 4 minus 0 equals to 3 by 4, and so many examples. After addition and subtraction, we learn the properties of rational numbers for multiplication. Similarly, here also the first property is closure property. The product of two rational numbers is always a rational number. Similarly, in addition, the sum of two rational numbers is always rational. In subtraction, the subtraction or difference of two rational numbers is always rational number. And same in multiplication, the product of two rational numbers is always a rational number. For example, 2 by 3 is a rational number, 1 by 5 is a rational number, and their product is 2 upon 15 is also a rational number. Similarly, next example, 3 by 7, a rational number, 1 by 2, also a rational number, and their product is also a rational number, 3 by 14. Now, the second property is commutative property. Two rational numbers can be multiplied in any order. Similarly, in addition, two rational numbers can be added in any order. But in subtraction, we can't subtract in any order. Like in multiplication, two rational numbers can be multiplied in any order. For example, 2 by 3 is a rational number, 7 by 5 is a rational number, and their product is 14 by 15. If we change their places, means change the order, 7 by 5 multiplied by 2 by 3 is also gives 14 by 15. Similarly, another example, 3 by 2 multiplied by 3 by 7, 3 3s are 9, 7 2s are 14. And the same if we change the places or we change the order, 3 by 7 multiplied by 3 by 2, the product is 9 by 14. The third property is associative property. In this property, we multiplying more than two rational numbers in any order, grouped in any order. For example, 2 by 3 multiply 1 by 5. First we multiply these two rational numbers. Then the product is multiplied by 2 by 5. The answer is 4 by 75. But if we change the group, first we multiply 1 by 5 multiplied by 2 by 5 and the product is multiplied by 2 by 3. The answer is also same 4 by 75. Now, the fourth property of the multiplication for rational numbers is multiplicative identity. In this property, the product of one and a rational number is the number itself. Means when we multiplied 1 by a rational number, it gives itself a rational number. For example, when we multiplied 1 to 3 by 4, it gives 3 by 4. 1 multiplied by 1 by 2, it gives 1 by 2. And similarly, there are so many examples. The fifth property for multiplication, the product of 0 and any rational number is always 0. For example, 1 by 2 multiplied by 0 gives 0. 3 by 4 multiplied 0 also gives 0. And the last property, multiplicative inverse. If any rational number multiplied by its reciprocal, it gives 1. If any rational number multiplied by its reciprocal, it gives 1. It means reciprocal is the multiplicative inverse of a rational number. For example, 3 by 4 is the reciprocal of 4 by 3. Therefore, when we multiplied by 3 by 4 multiplied by 4 by 3, the resultant answer is 1 because 3, 4 cancelled equals to 1. Now, properties of rational numbers for division. The first property is closure property. Same. When we divide two rational numbers, it always gives a rational number. When we divide two rational numbers, the resultant number is also a rational number. For example, 3 by 4 divided by 1 by 5 is equals to 3 by 4 multiplied by 5 by 1 because in division we reciprocal the last number and the resultant answer is 5 3s are 15 by 4 and 15 by 4 is also a rational number. The second property is commutative property. Two rational numbers cannot be divided in any order. In multiplication, we studied that two rational numbers can be multiplied in any order. But in division, we can't divide it in any order, the two rational numbers. For example, 3 by 4 is a rational number, 1 by 5 is also a rational number, and their division gives 15 by 4. But if we change the order, 1 by 5 divided by 3 by 4, it gives 4 by 15, and these two rational numbers are not same or equal. The third property is associative property. While dividing more than two rational numbers, they cannot be grouped in any order. For example, 3 by 5 divided by 1 by 2 divided by 2 by 3. Here we first grouped the two rational numbers 3 by 5 divided by 1 by 2 then the resultant answer is divided by 2 by 3 and the answer is 18 by 10. But the answer is 18 by 10. But when we change the group is 1 by 2 divided by 2 by 3 and then divided by 3 by 5. The answer is 12 by 15 and both two rational numbers are not equal. The next property is any rational number divided by itself. If any rational number divided by itself, it gives always 1. For example, 3 by 2 divided by itself means 3 by 2 divided by 3 by 2. The resultant answer is 1. And the last property, if 0 is divided by a rational number, it gives a 0. 0 is divided by a rational number, it gives 0. For example, 0 divided by 3 by 2 is equals to 0. But a rational number is divided by 0. The answer is not defined. For example, 3 by 2 divided by 0 is equals to not defined. Students, now we meet in our next video, and I will teach you in this video how to represent the rational numbers on the number line and some other types of questions. Thank you.